Problem 66 states that astronauts use a centrifuge to stimulate the acceleration of a rocket launch. The centrifuge takes 30 seconds to speed up from rest to its top speed of one rotation every 1.3 seconds. The astronaut is strapped into a seat 6.0 meters from the axis. So for A, it wants to know what is the astronaut's tangential acceleration during the first 30 seconds. So we started by drawing it out, and here's our centrifuge, which are with our astronaut 6 meters from the axis, and his final angular velocity is going to be 1 revolution per 1.3 seconds. So I want to convert that into radians per second, so we know times it by 2 pi radians equals 1 revolution, and we get 4.83 radians per second for his final angular velocity. His initial angular velocity is 0 radians per second, so we know the change in his angular velocity is going to be 4.83 radians per second. We are also given the radius, which is 6.0 meters, and the time it takes to get to that final angular velocity, which is 30 seconds. So to get our angular acceleration, we just use this equation here. We do the change in angular velocity over the change in time, which we can plug in our numbers there, and we get our angular acceleration is 0.161 radians per second squared. Next, we can use that angular acceleration to find our tangential acceleration, which we just times it by the radius, which is 6.0 meters, and have our final tangential acceleration at 0.966 meters per second squared. All right, so for question B, they want to know how many g's of acceleration does the astronaut experience when the device is rotating at a top speed. Each 9.8 meters per second squared of acceleration is 1 g. So we want to find the velocity that he's traveling at top speed. So here's our equation that we're going to need to find his acceleration, and we need to find the velocity first. So we use the 2 pi radius over time to find the velocity, which we can plug in. We know he's 6 meters is our radius. We know 1.3 seconds is the time, and we get 29.0 meters per second for his velocity at that final his final velocity. So now we can plug that in to find his acceleration. Acceleration is 4.833 meters per second squared, and now we just want to divide that by that gravitational force, and we find that acceleration is 0.493 g's. And the context that this question teaches us is to understand the angular acceleration and the kinematics of non-uniform circular motion.